First off, I'd like to thank you for purchasing CLN equipment. This is the CLN 2010 notching machine. It's fully assembled, and in this video we're going to show you how to troubleshoot, run the machine, and do routine maintenance. You're going to want to locate this manual upon receiving your machine. Refer to the manual throughout the setup procedure. Installing your monitor and keyboard. What you want to do is locate your monitor arm. Bolt it to the machine with the 4 1/4-20 bolts located here. Then bolt your monitor to the arm. Put the keyboard tray in and set your keyboard inside, along with the mouse. Inside the frame, pull out the 2 wires. One will be marked green, one will be marked purple. Plug the green wire into your mouse, which will be green. Locate the purple wire, which will be your keyboard, and plug them in like so. They only go one way. Be careful not to force them. Install the air filter regulator in the bracket located on the side of the machine. Remove the nut from the air filter regulator. Slide it up into the bracket and put the nut on like so. Then there's an air hose located behind. Stick it through the hole that's in the machine and plug it into the connector on the air filter regulator. Your air supply goes into the side of the regulator marked in. Read your gauge. If your gauge does not read 80 psi, grab the top of the air filter regulator until the red line is shown. Rotate clockwise until your gauge reaches 80. Bolt the power feed decoiler on with 3/8/16 bolts located here and here. Then plug it into the side of the machine. Once you bolt the power feed decoiler to the machine, then bolt the limit switch rod to the power feed decoiler. Use the 2 3/8 bolts located here. Try to keep about a 3-inch clearance between the floor and the bottom of your rod. Bolt the straightener to the side of the machine. Use the 4 3/8 bolts. Make sure that the 2 rollers are on the bottom and the lever that adjusts the tension is to the front of the machine. The main power source plugs into the side of the machine located here. Right now we're going to talk about all the different components in the machine and how they work. This is the straightener. The purpose of the straightener is to take the memory out of the coil. How it works is you pull this little lever out and adjust this arm down. That causes this top roller to come down lower. Right now we're going to talk about the internal components of the machine and how they work. What actually guides the channel letter return through the machine are 4 V-groove rollers. 2 stationary ones located in the back and 2 adjustable ones located up front. It's important that the V-groove in the roller right here goes into the channel letter edge. Then tighten the lever. Roll the material back and forth and make sure you have good contact with the return. What moves the material through the machine is your drive box. Inside this box there are 2 drive rollers. Now right now with the cover open, you're able to push the material back and forth. When you bring the cover down, it actually activates 2 cylinders inside the box, which tightens the pinch rollers, and that's what makes contact and allows this to move under the computer's control. This device right here is a limit switch. It acts as a home switch. The purpose of it is to find the edge of the channel letter return. Now let me show you how it works. If the material is under the switch, the machine will back up until the switch is opened. Then the machine will move forward until it closes the switch. Now the machine knows where the edge of the channel letter return is. What we're going to talk about next are the notchers. Right here we have the 30-degree notcher, then the 100-degree notcher. This plate right here prevents the return from riding up into the notcher. These tools right here are your dimplers, and they put a dimple in the channel letter return. This station here fires 2 dimples, and that'll line up with your 30-degree notch. That'll always be a negative bend. This dimple is a single dimple, and it lines up with the 100-degree notch, and that'll be a positive bend. This is your flanging station. How this works is this is a clamp. This comes down to hold the material in place. Then this is your flanging blade. This comes down to bend the 90-degree flange on the back side of your channel letter. This is the shear. The purpose of the shear is to cut the return off of the coil. Now we're behind the machine. This is your 8-station manifold. Each one of these stations controls a tool in your machine. When the computer commands the machine to do something, this connector will actually light up. If you're getting a light on your connector and the tool is not activating, then you have a problem with your valve. To test that, you can just come under here and push this button, and that manually overrides the valve. So if you push the button and the tool doesn't work, you know for sure your valve's bad. To power up the machine, turn the main power switch on. Wait for a moment, then press the startup button. This button here starts your computer. The light should turn red, indicating that your computer is now starting. After powering up the machine, press the reset button once before starting your program. This is your emergency stop switch. In the event there's an emergency, simply smack the switch. It'll kill all power to the machine. To release the switch, simply twist the switch. We're going to load a channel letter coil into the machine right now. Loosen the guide rollers to the front of the machine. Put your coil inside and take the adjustable guide and slide it up to the channel letter coil. Lock it in place. Take the end of the channel letter coil, pull some material out. Now, this is your limit switch. When the material bumps into the limit switch, it turns on the motor, which moves the coil forward through the machine. So take the material out, go over the top of your rod, and stick it into the edge, the leading edge of the straightener. Now, you have to be very careful at this point not to damage the encoder. The encoder is pretty vulnerable at this point. I'm going to feed the material through the machine and try to get it into the V-groove rollers. Now, something I got to show you. Let me move these out of the way. You see your limit switch? If you bring material into the machine this way and push it into the side of that switch, you're going to break the limit switch. You have to bring the material into the machine from this direction. So the best thing you could do is make sure that you're in your V-groove rollers really good. Then slide your adjustable rollers up to the return. Lock them in place like so. Make sure all 4 wheels are spinning. That one's not spinning, so I'm going to make an adjustment here. Like that. Now we're going to process the channel letter return. The first thing that you need to do is save the DXF file to the computer's hard drive. Then open the CLN program. Double-click on the desktop icon. Go to File, Open, double-click on the computer's hard drive, double-click on the folder that you saved the DXF file to, then double-click on your DXF file. The next thing that you want to do is set your start point. You can click rotate point plus, rotate point minus. That will alter the start point around the letter. Then you want to select the tab type. You have a choice of lead tab, trailing tab, both tabs, or no tab. Your tab will be displayed in the top right corner of the CLN program. Now there's 3 ways to process the letters. The first way is select the letter and click Reset Tool, which will bring the cover down. Then press Run Tool. The second way to process a letter is go to Options, Repeat Image Count, and here you can select up or down and select how many times you want to run that one letter. Click OK, then click Run Tool. The third way is to run the entire job. For that, go to Options, Continuous Job, then click Run Tool. As the machine is processing the letters will be highlighted as they're being processed, so you know which letter is being processed. For a complete description on the program settings, review the user's manual. This is a Helvetica Bold R. It's pre-notched, ready for bending. The return has 100-degree notch for a positive bend, 30-degree notches for negative bends. All your radiuses are all notched out and your flange is bent. Plus you have dimples in the return to indicate which direction to bend the letter. If you turn your main power switch on and you don't hear a fan or see the green LED ready light, then chances are your emergency stop switch has been pushed. Simply twist the switch. To get the most out of your machine, you must understand exactly how it works. Now, it's a step motor fed machine. The step motor pushes the material through the machine while the encoder monitors the material that feeds through it. So let's just say we tell the machine to make a 48-inch move. It'll make that move. Before the machine does anything, it stops and asks the encoder, did he go exactly 48 inches? And if not, the encoder tells the step motor to make a correction. So they call that step motor maintenance. Before you make any adjustments to the computer, the first thing you need to do is test your encoder tension. Now, your encoder should only come up off the material by about 3/16 of an inch, and it should stop on its own internal spring. It should not bump the support bar right here. It should stop on its internal spring. Now this encoder is set correctly. However, I'm going to show you how to adjust it. Remove the rubber cap. Use a small Allen wrench that should have came with your machine. And locate the set screw in the back end of the encoder. Loosen the set screw, lift the wrench, and snug up the set screw. Then test. This one's a little too loose, so I'm going to raise it up a little more. Adjust it until the wheel comes up off of the return by 3/16 of an inch. Tighten the set screw down. Then replace the cap. Now we're going to talk a little bit about how to test for calibration errors. I want to show you a quick way to see if your machine is running correctly. The easiest way to do it is take a tape measure and hook it onto the edge of your return. Now, every 12 inches, you should have a 30-degree notch. That notch is there as a relief for the flanger. Has nothing to do with the DXF file. It's just something the machine does automatically. So if you don't have a notch exactly on 12 inches, the machine needs calibration. Here I can see that my notches are actually getting shorter by a 1/16 at every 12-inch increment. So I know by measuring this that the calibration is a little short. And I can double check that by coming over to my 12-inch mark. I'm really close to 12 inches. But here I'm short, and I progressively get shorter as I go down the line. So what we're going to do is we're going to have to add to our encoder count value. You need to know how to use setup2.dat. Setup2.dat is where adjustments can be made to the machine. It is a file that opens in Notepad. Go to your hard drive, go to your Notcher folder, and double-click on setup2.dat. Be careful not to accidentally change anything. If you are not sure about a change that you made, then close without saving and start over. After you make a change to setup2.dat, save the changes. You must close the CLN program and reopen it. The information in the setup.dat file is downloaded to the controller when the CLN program is started. Now I want to show you how to manually calibrate your machine. The first thing you need to do is get a square and a pencil. What we're going to do is draw a straight line on our return. Now I'm going to slide my square up against the straightener and draw a line. Now this is a reference point. Very important. Now we're going to use a tape measure and exactly measure out 48 inches. Now I'm going to burn an inch to get a precise mark. Now I'm going to make the machine move 48 inches and test to see if my second mark lines up where my first mark was, up against the straightener. Now I'm going to use my square and again bump it up against the straightener and make a new mark. Now I realize that the material actually is short. So what I'm going to do is measure exactly how much short the material is. So now the material is 1/4 inch short. That means the material moved 47 3/4 inches. Now we're going to go into the software and make an adjustment. Now that we've just made our move and we found out that the material is moving 47 3/4 inches, we have to go into Setup 2 and make a correction to our CPI value. In order to do this, we're going to have to do some math. What you want to do is take your commanded distance and divide it by your actual distance that the material moved and multiply that by your current CPI value. So what we have here is we told the machine to move 48 inches. I take 48 and I divide that by 47.75 and I'm going to multiply that by 1654.25. That gives me a new value of 1662.91. And we're going to go ahead and put that into our new CPI value right here. After you make a change, you have to close Setup 2, save your changes, and restart the Notcher program. The changes that you make to Setup 2 get downloaded when the Notcher program is started. Now that we just made a change in the software, we're going to test to see if the change we made is correct. So the first thing we're going to do is open the cover and pull the material back to our first mark. Okay, now we're going to close the cover and we're going to make the material move 48 inches and test to see if the material moves exactly 48 inches. And we're exactly where we need to be. We moved exactly 48 inches. There is another value to adjust. If you notice your machine starting to work slowly or make a lot of tiny little moves, then you're going to have to go in to the step motor calibration. It is exactly the same way that you adjust the encoder counts. You do it the same way. You're going to put a mark, you're going to measure out 48 inches, and you're going to make a move. But this time, you're going to use uncalibrated move in the program. Now that we've changed our encoder counts, I want to show you how to adjust your step motor counts. Go to the computer's hard drive, double-click on the notching folder, and double-click setup2.dat. It'll open in Notepad. Now you do the exact same math as you did for the encoder counts as you will for your step motor counts. But this time you want to change your SPCNT value. To test the limit switch, all you have to do is move the material under it. Now you should hear a click. If you hear the limit switch clicking, then it's adjusted correctly. If there is no clicking, what you want to do is adjust the switch down. Now you can do that in a couple ways. If you're careful, you can grab that metal lever and bend it down slightly. Or you can go behind the machine and loosen the bolt that holds the whole assembly on and lower it down a little bit. If the material is allowed to ride up, it may pre-trigger the switch. So the purpose of this Lexan finger is to make sure the material stays down. So if you imagine this finger comes up, the material would be allowed to pre-trigger that switch. And if that happens, the beginning edge of your material will be long or short. And it just wouldn't be consistent. This piece of Lexan right here prevents the return from riding up into the top of the notcher. So how to test that is you stick your finger up through the bottom of the machine and push up on the return. With your other hand, push down. You should have about 1/16 of an inch of clearance in between the Lexan plate and the bottom of the machine. If not, you can loosen your jam nut and adjust your jack bolt. The same is true for the 100-degree notcher. Let me show you how to adjust the flanging station. Now, if you put a square on your flange and it's not bending a 90-degree bend, you may have to adjust your flanging blade. Now let me just kind of show you how this works. It's tough to see, but down in here is a die. It's a sharp edge. See that blue thing down in there? That's the edge of your die. This is your flanging ram. What actually adjusts the degree of the bend is the distance from the flanging ram to your die. And how you adjust that in and out, you have to loosen 4 bolts located underneath the flanging die. Then, once they're loose, stick a screwdriver in between the die and the flanging ram on one side. Make an adjustment to the thumb bolt. And I'm using the screwdriver as pressure, as to keep any backlash out of the threads. And if you turn this thumb bolt clockwise, it'll pull the flanging ram closer. Counterclockwise, it pushes it away. Now I can feel the blade moving in my right hand. Keep pressure against the blade and tighten my thumb bolts located underneath the machine. And that's how you adjust the flanging ram. Now I'm going to show you how to adjust the tolerance between the shear blades. Now we're behind the machine. This is your 8-station manifold. Station number 4 is your shear. Lock the shear into place, push it up and turn it clockwise a quarter turn. Now we're going to go around to the front of the machine and we're going to adjust the blade tolerance. This shear is set correctly. There should be no gap between the two blades. However, I'm going to show you how to adjust it. Now, there's a plate of metal in here that acts as a shim, and there's 2 quarter 20s that push against it, maintaining a tight gap between the blades. So let me show you how to adjust it. First, you want to loosen the jam nut. Make an adjustment to the jack bolt and tighten the jam nut. Then go around to the back of the machine and release the valve. Right now I'd like to talk to you about tool timing. If you go to your computer's hard drive and double click on your notching folder, then double click on setup2.dat, setup2.dat will open in Notepad. In there, along with your encoder counts and step motor counts, you have all these tool timings. We have our 30-degree notcher, our 105-degree notch. We have our clamp, a flange, double dimple, and single dimple. Now, we also have our shear. Now, all these are simply delays for the output routines. They have nothing to do with the speed of the material or the speed of the tool. It has nothing to do with that. What it does is that the machine will actually turn on an output, which turns on a valve. And it says, well, how long do you want me to stay on? In this case, let's look at the 30-degree notcher. In this case, the 30-degree notcher down delay is set to 75. Now, we have down 30. Down 30 is just a variable. Down 30 is equal to 75. And 75 is in milliseconds. You have 1,000 milliseconds equal 1 second. So in this case, down 30 is equal to 75. So let's just say that the notcher goes and takes a notch and it doesn't go through the material all the way. It needs a little more time to get through the material. So I would take down 30 and make it, add 100 to it, make it 175. That would be 175 milliseconds for it to get down through the material. Now, let's go down to up 30. Up 30 equals 175. This is the time it takes for the notcher to come back up through the material. Now, like I said, it has nothing to do with the speed of what the notcher travels. It's all about how long it takes before the material starts moving again. So in this case, up 30 is equal to 175. It's 175 milliseconds of time. If the notcher isn't getting up fast enough, I'd add 100 to that, make it 275, and then go ahead and run the machine and see if the notcher is coming up above the material before the material begins feeding again. All the delays in here, your notcher down, your clamp, flanger, double dimple, single dimple, and your shear, they all work the same way. It's all about turning something on, waiting, turning something off, and waiting. On behalf of everybody at CLN, I'd like to thank you for purchasing CLN equipment. If you have any questions whatsoever about our machines, feel free to call our technical support hotline anytime. Thank you.